Hello everyone, welcome to Math EduTop. Today we study the most important point of differentiation, that is the derivative of composite function. It is also known as chain rule. In last standard already you have studied the composite function. The composite function means composition of two function. Then here the one more step is there. We have to find the derivative of composite function. Then how to find derivative of composite function? By using the chain rule. Then first of all, the composite function means if y is equal to f of u, here y is equal to f of u and u is equal to g of x, then if y is equal to f of u and u is equal to g of x, means y is a function of u and u is again a function of x, then in place of u, here in place of u we substitute g of x. When we substitute in function f u as a g of x, finally we get y is equal to f of g of x, means this y is expressed in terms of x, means y is a composite function of x. Means already we have studied how to find composite function in last standard. Means if we have provided the y is equal to function and inside value we substitute this as, means here u is given g of x, we substitute this u as a g of x, means finally we get y as a composite function of f of g of x, that is y is a function of x. Then the next one we study the theorem how to differentiate this composite function. Means if y is equal to f of u is a differentiable function of u and u is equal to g of x is a differentiable function of x, then the composite function y is equal to f of u is a differentiable function of x, means this finally this y is a function of x, means for this left hand we have dy by dx, and for the right hand means we differentiate this y first with respect to u, then dy by du into u is again a function of x, means we differentiate this u with respect to x, means du by dx. Then for example, the y is equal to sin x cube is also a composite function of x. Then we study some important topics to composite function. Means here y is a function of u and u is a function of x. Sometimes it is happen that is y is a function of u is again a function of another function, means suppose u is a function of v and v is again a function of suppose w. Then how to differentiate when it is a composite function of more than 2-3 functions? Then related to this, the first one, if the derivative of composite function is expressed y is equal to f of u and this u is a differentiable function of x, then the finally y is a function of x, means dy by dx, that is y is equal to f of g of x, then left hand y is function of x means dy by dx, and for the right hand f of g of x. To differentiate this f of g of x, the composite function differentiation, always remember we differentiate this outside function first and inside function keep as it is, means this f derivative is f dash, because this y is a function of f first and then again g of x, means this outside function derivative first f dash into this inside function remain as it is into derivative of g of x, means this g dash of x is there, that is same thing is dy by dx is equal to dy by du and into du by dx, means y is a function of f of u, it's a derivative f dash and u is g of x remain as it is into du by dx, means the derivative of this g of x is g dash of x. Then the next one, that is if y is equal to f of v and again v is a function of u and u is again a function of x, means finally y is a composite function of x. Okay, that is finally this y is a finally the composite function of x, means we differentiate this y with respect to x dy by dx, and then dy is a function of v, means differentiate this y with respect to v first dy by dv, and then v is a function of u, means differentiate v with respect to u into u is a function of x, means differentiate this u with respect to x, that is we get dy by dv into dv by du and then du by dx. Then here y is a function of v, then u, and then x. Then same thing, if y is a differential function of u1, u2, u3 up to ui, I is varies from 1 to 1, 2, 3 up to n terms, means finally this y is a function of x. This y is a function of x means for the left hand side we have dy by dx, and for the right hand side y is a first function of u1 means dy by du1, then u1 is a function of u2 means derivative of u1 with respect to u2, and then u2 is a function of u3 means u2 derivative with respect to u3, and finally this un derivative with respect to x means this one dy by dx, y with respect to u1, then u1 with respect to u2, then u2 with respect to u3, and then up to un, un again, that is finally the un is a function of x means du by dun by dx. Then the derivative of standard composite function. Then here lastly in differentiation we have find the derivative of standard function. Here something as this one, but here whatever the standard function is again a composite function, means here to find derivative of composite function we have to use a chain rule, means function of function, means here f of x raised to power n derivative, that is we have find x raised to n derivative and it is n into x raised to power n minus 1, but here f of x raised to n derivative is something as x raised to n, that is n into x raised to n minus 1, but into f of x derivative also exists and it is f dash of x. Then same thing, the root of f of x derivative, the root x derivative we know that it is 1 upon 2 into root x, but here root of f of x is 1 upon 2 into root of f of x into derivative of f of x is f dash of x because it is a composite function. Then 1 upon f of x raised to power n, it is minus n upon f of x raised to power n plus 1 into derivative of f of x is f dash of x. Then same thing we know that derivative of sin x is cos x. Then sin of f of x means differentiate this outside function first and then this inside function f of x. Okay, that is always remember for composite function differentiate outside function first and then the inside function. Okay, means derivative of sin x is cos, inside function remain as it is f of x, means derivative of sin of f of x is cos of f of x first and into derivative of f of x is f dash of x. Then cos derivative we know that it is minus times sin, means sin minus times sin of f of x into derivative inside function f dash of x. Then tan x derivative we know that it is secure, then something here secure of f of x into derivative of f dash of x. Then sec x derivative we know that it is sec x into tan x, then same thing here in place of x it is f of x, means sec of f of x into tan of f of x into f dash of x. Then cot x derivative we know that it is minus cosec square x, then here minus cosec square f of x into derivative of this f of x is f dash of x. Then minus cosec of f of cosec of f of x derivative is cosec x derivative is minus cosec into cot x, then here cosec of f of x is minus cosec f of x into cot f of x and into derivative of f of x is f dash of x. Then a raised to x derivative is a raised to x into log a, then here also a raised to f of x into log a into derivative of this f of x is f dash of x. Then we know that a raised to x derivative is again a raised to x, but here a raised to f of x means a raised to f of x into derivative of this f of x is f dash of x. Okay, then log of x, the derivative of log of x is 1 upon x, but log of f of x is 1 upon f of x into derivative of f of x as f dash of x. Then the log base is a of f of x, then its derivative is 1 upon f of x into log a in and that is into derivative of f of x as f dash of x. And then the nextly we study how to find actual derivative of composite function by some examples. Then the example 1, they differentiate the function y is equal to square root of x square plus 5 is given. Then how to differentiate this? Then to differentiate this type of example, here startingly first we solve this example by using two methods. After that we solve this example by using this second method only, because it is a simple method and time consuming method. Okay, then here the first y is equal to the square root x square 5. Let we suppose u is equal to inside term is x square plus 5. Then we get y is equal to root x, where y is a differentiable function of u and u is a differentiable function of x. Means here we are express this y as a composite function of x, because we have substituted x square plus 5 as a u. Means we get y is equal to root u and u is again a function of x. Means we get the y as a composite function of x, means dy by dx is equal to y is a function of u, means dy by du, into u is a function of x, means du by dx. Okay, that is we get a formula by using the method 1, dy by dx as dy by du into du by dx. Means we differentiate this root of u and then u with respect to x. Okay, therefore now y is root of u, differentiate with respect to u first, means differentiate this y with respect to u. Then we know that root x derivative is 1 upon 2 into root x. Then using the same thing, this derivative of root u is 1 upon 2 root u, and u means here x square plus 5. This is the value of dy by du. Okay, dy by du is 1 upon 2 root u, into we have to find du by dx. Then when we differentiate this u with respect to x, we get du by dx. Okay, then we differentiate this u with respect to x, means u is x square plus 5, then this derivative is 2x. Okay, we know that how to find derivative. X square derivative is 2x and constant derivative is 0, then it is 2x. Means here we get dy by du as 1 upon 2 root u and this du by dx as 2x. Means we substitute this dy by du value and this du by dx value in equation 1. What is the equation 1? That is dy by dx is equal to dy by du into du by dx. Then we substitute this value, that is equation 1 becomes 1 upon 2 root u into 2x. Then here this 2 and this 2 get cancelled, then remain is 1 upon root u into x, and what is a u? U is x square plus 5. Then we substitute this value, that is we get x divided square root of x square plus 5 as the value of dy by dx. Then this is by using method 1. Then for the second method, here we directly differentiate this y with respect to x, keeping this value of u in mind, and directly we differentiate. Then let us see, here we have y is equal to the square root of x square plus 5. Means here we have directly consider y is equal to square root x square plus 5 value, and directly we differentiate this with respect to x. That is, in first step we do step by step, means we differentiate y with respect to u and then u with respect to x. But in second step we directly differentiate this y with respect to x, means the derivative of y with respect to x, y square root x square plus 5. And we know that differentiation of square root term means differentiate this square root term first and then this inside term means x square plus 5. Okay, that is, keep this x square plus 5 as a u in mind and then differentiate this square root term. Square root means x square plus 5 raised to 1 half. Use the formula of x raised to power n. Then what we get derivative as this, as when we keep this u as x square plus 5 is in mind and we differentiate this root u. Root u means square root of x square plus 5. Then this derivative is 1 upon 2 into root of x square plus 5 into derivative of inside term. Means here we differentiate this square root, that is x square plus 5 raised to 1 half power, that is 1 half into x raised to plus 5 raised to 1 minus 1 half, that is minus 1 half into derivative of inside term, is differentiate outside term and then inside term. Okay, then this 1 upon 2 root x square plus 5 into derivative of this x square plus 5 as 2x. Then finally what we get, this 2x divided 2 into square root x square plus 5, that is this 2 and this 2 get cancelled, remain is x upon x square plus 5. Means directly here in the second method we differentiate this y as a with respect to x, because y is a function of x. Then method second, the same thing example we solve by using second method, means here we directly differentiate this y with respect to x. This same thing, the next one example is there, y is equal to sine of log x. Then here also y is a composite function of x, means we differentiate this y with respect to x. For the left hand we have dy by dx, and for the right hand we have derivative of sine of log x. That is, in first we find derivative of sine. At that time we take log x constant and into derivative of this inside term, that is into derivative of this log x. Okay, that is we differentiate with respect to x, then we get dy by dx as derivative of sine of log x. We know that sine derivative is cos, means cos of log x remain as it is, and into derivative of log x, because we are keep in mind log x has some value u. Okay, then we get this, the derivative of sine x as cos of log x, and into derivative of log x, we know that derivative of log x is 1 upon x, means we get dy by dx as cos of log x into 1 upon x. Okay, that is cos of log x divided by x, which is the value of dy by dx. That is, we differentiate this outside term and then this inside term for the composite function. The next one example is there, y is equal to e raised to tan x. Then exponential function derivative we have find in standard 11, that is e raised to x derivative is e raised to x, but into tan x function is there. That is, here we get e raised to tan x derivative as e raised to tan x into derivative of tan x we have to find. That is same thing. This standard formula is e raised to f of x. E raised to f of x derivative is e raised to f of x into derivative of f dash of x, because here f of x is tan x. Then differentiate this with respect to x, that is a derivative of e raised to tan x. Then exponential derivative e raised to tan x into derivative of tan x, that is e raised to f of x into derivative of f dash of x. That is, here f of x is tan x and its derivative of tan x is sec of x. That is, we get dy by dx as e raised to tan x exponential into f dash of x, that is sec of x. That is, then this is the value of derivative. Then next one example is there, y is equal to log of x square plus 4. Here also y is a function of x, means differentiate this y with respect to x, dy by dx. Then first derivative of log and into derivative of this x square plus 4. The log of x derivative is 1 upon reciprocal and into derivative of this x square plus 4. Okay, then differentiate this with respect to x, we get dy by dx is equal to derivative of logarithmic term into derivative of this inside term, means outside term derivative log term derivative into inside term derivative with respect to x. And then this log x derivative is 1 upon x. Then same thing here, log of x square plus 4 derivative is 1 upon x square plus 4 into derivative of this x square plus 4 is 2x. That is, we get this 1 upon x square plus 4 into 2x, that is dy by dx is equal to 2x divided x square plus 4 as the derivative. The next one example is y is equal to log to the base 3 into log 5 x. Then here 3 and 5 is at the base, means to find differentiation of y is a composite function of x, means to find differentiation of y with respect to x, we have to first simplify this logarithmic term by using some rules of logarithmic. Then here we use the first rule, that is change of base log. Okay, means log a b, log a is base and rest to b, then this simplification is log b upon log a. Then here we get log x upon log 5 and this outside log 3 remain as it is, means what we get, y is equal to log 3 remain as it is and this inside term change log x upon log 5. Then again here we have to use one result, this log of y, log a upon log b is log y into log a minus log y into log b. Then same thing here, log 3 into log x, log 3 into log 5. Then again this log 3 is at the base and rest to log x term is there, means consider this term as some constant a. Okay, then same thing, this log 5, consider this term as some constant a or b. Means log 3 raised to a, what is this simplification? Log b, log a raised to b, log b upon log a. Means log 3 raised to a, simplification is log a upon log 3, and this log a means log x, means log of log x upon log 3. Okay, and here also log a upon log 3, and a means again log 5, means log of log 5 divided log 3. Okay, means log 3 raised to a, means log a upon log 3, a substitute log x again, means here we get log of log x divided log 3 minus log of log 5 divided log 3, and then here we differentiate this with respect to x. Then when we differentiate with respect to x, we know that if k into some function or k into x is there, then we keep this constant term outside, and then we find derivative of this inside term, that is x. Then same thing here, log 3 is a constant, keep this log 3 as outside, means 1 upon log 3 into derivative of log x. Then for this differentiation, suppose we call this log x as some constant a. Okay, we call this log x as a, means what we get, 1 upon log 3 into derivative of this log of log x, means log a. Okay, that is what we get, 1 upon, differentiate with respect to x, 1 upon log 3 constant into derivative of this log of log x. Okay, means if we consider this log x as some a, okay, we have considered this log x as some a, means log a derivative is 1 upon a. Okay, and this a means log x, means 1 upon a into derivative of this a, means 1 upon a is log x, means 1 upon log x into derivative of a, means derivative of log x. Okay, here 1 upon log 3 constant, log of log x derivative 1 upon log x into derivative of this log x, and this constant derivative, that is 0, means right hand term it is 0. Then this log x derivative is again 1 upon x, means we get 1 upon log 3 constant term into this log of log x derivative is 1 upon log x, that is 1 upon log a, and a means log x, means 1 upon log x into derivative of this a is log x, means derivative of log x is 1 upon x, means what we get, 1 upon log 3 into 1 upon log x into 1 upon x, that is dy by dx is equal to 1 upon x into log x into log 3, which is the derivative of this function. Here we have used the sum laws of logarithm, that is change of base property. Then in next video we study this sum exercise depending on this composite function. So remain connected. Thank you for watching this video. Like, share and comments this channel. Thank you.